So we begin one of our problems in Chapter 5. We're looking at problem 36 on page 208 of the text. A company audit showed that of 875 bills that were sent out, 623 were paid on time, 155 were paid up to 30 days late, 78 were paid between 31 and 90 days late, and 19 were paid after 90 days. If one bill is selected at random, the first question is, what is the probability that a bill is paid on time? The second is, what is the probability that the bill was paid late? Well, the solutions are the following. We know that the probability of any event A is equal to the number of occurrences or a number that occur divided by the total sample space. And so in this case, the total number of bills for Part A was 875. The number that were paid on time is 623. So the probability on time is just the ratio of 623 over 875. That gives us 0.712, or if we multiply it by percentage, it would be 71.2% of the bills are paid on time. If you're a company, that may be a good thing. So then the question is, what's the probability that the bills were paid late? Well, the best way to do that is whatever's not paid on time is probably considered late. So what we do is we calculate the number that is paid late, and we kind of call this a complement of an event. And so what we did is we subtracted 623 from 875, and we got 252 bills that were late. So the probability of being late is just the ratio of 252 divided by 875, which is 0.288. And in percentages, that would be 28.8%. So 28.8% of the bills were paid late for this company. Problem 42 on page 208 is our second problem we're going to look at. Sometimes problems are shown in a frequency table, and so in this case, this portion of the table is shown to us. Whenever we get a frequency table and we want to know probabilities, typically we calculate a relative frequency. And the relative frequencies are really nothing more than our probabilities of events. And so in this particular case, we calculated the relative frequencies. We took the number of lung cancer, for example, 128,900, and we divided it by the total. And when we did that, we ended up with 0.29097. And so one of our questions is, well, the problem starts out, don't smoke. The Center of Disease Control and Prevention reported that there were 443,000 smoke-related deaths in the United States in a recent year. The number of deaths caused by various illnesses attributed to smoking are as follows. Here they are. Part A is, what is the probability that a smoking-related death was the result of lung cancer? And if we look at our relative frequency, we can see that the probability of lung cancer deaths is 0.291%, or 29.1%. So that was our calculation. And our second sentence, or our second problem is, what is the probability that a smoking-related death was the result of either isometric heart disease or other. And so in this particular case, we're looking at this cell and this cell, and we add those two probabilities up because they're not overlapping. And when we do that, we get a total of approximately 0.499 or 49.9%. The idea in this problem is that if we do have a relative frequency distribution based on categories, we can first get the relative frequencies to calculate probabilities. That ends our problems in Chapter 5-1.